Before I go into solving this problem, no, I've edited the video a little bit. My first time through I made a mistake and didn't want to redo the whole thing. So you'll see a quick mistake being made with my moles of HCl. I will correct it before I keep going in the problem. It's just a calculator error. Everything I'm explaining is correct. This is an acid plus base problem. So slightly different than my acid plus acid problem. From the acid, I want to find moles of H. From the base, I want to find moles of OH. And then rather than finding total moles, because each mole of H and each mole of OH will neutralize each other, I want to just know who wins. Which one am I going to have left over? If I have leftover H, we end up with something acidic. If I have leftover OH, we end up with something basic. So for the acid, HCl, molarity is moles over liters. The moles that I've found are of my HCl, but because of a 1-to-1 ratio, if you want to see that ratio, look for an example like it, number 14. That's my moles of H+. For the base, I want to find moles of OH. Now calcium hydroxide, they didn't give me a molarity, they gave me grams instead. That's okay. Grams equals moles. It was grams of calcium hydroxide, so I need to find moles of calcium hydroxide using molecular weight of CaOH2, calcium hydroxide. Grams divided by molecular weight gets me my moles, but those moles are of CaOH2. Not all strong bases have a 1-to-1 ratio. I can tell from looking at this is not a 1-to-1 ratio, so I definitely need to show the ratio so that I don't accidentally get it backwards, multiplying when I should divide or vice versa. Where the ratio comes from, calcium hydroxide is strong, so it dissociates with a single arrow. The ions split apart, and I balance it. Again, what I care about from the base is the moles of the hydroxide. 1-to-2 ratio. For every 1 calcium hydroxide, I will have 2 hydroxides. On this side, I can use moles or molarity. What I have is moles. I have the moles of calcium hydroxide. So I'm doing this whole thing to find the moles of just hydroxide. In this case, it means multiplying by 2. Okay, before I go on, I realize I made a mistake. 0.2 times 0.02 is 0.004. It matters a lot because what I need to do now is evaluate which one I have left over of. Every mole of H and every mole of OH are going to neutralize each other until I run out of one of them. I'm going to run out of H plus first because that's a smaller number. So let's see, of the 0.0082 moles of hydroxide, I can subtract out the part that would react with the 0.004 moles of hydrogen and see that I end up with 0.0042 moles of hydroxide left over. I still combined this acid and base, so I still am going to want to find molarity using total volume. It's just the molarity I'm going to find has to be of hydroxide because that's what I have the extra moles of. And I still want to use total volume, but I only have one volume. 20 milliliters is a volume, grams is not a volume. So I am still adding the volumes, it's just this has no volume essentially, 0. So I'm going to use 0.02. That found me my molarity of OH to be 0.21. If I negative log my OH molarity, I will have my POH, 0.68. If I subtract that from 14, I will get my pH. And I'm done.